Okay, can everybody see the meeting? Okay, I apologize. There's a connection issue. So, okay, good. Okay. Wonderful. Let me double check that the Zoom is already recorded. Let's see. Okay, it's recorded. Okay, let's wait a few seconds so that everybody can join. Okay. Okay, that's wonderful. I think all the connection issue have been solved. So I apologize for this kind of technical issue. And so we can start. So today that will be the kind of first session for after the spring break, right? So and everybody I think is somehow trying very hard to move the entire class online. So that's something, this is especially hard for some other course. So they rely on the kind of hands-on labs. But for our course, somehow it's kind of easier, right? We can actually give like remote lectures. So pretty much that I will cover some I will pretty much highlighted some changes for the syllabus and some kind of what's the new things for this kind of entirely online lecturing. Okay. So pretty much that in the last lecture we talked about the kind of KKD conditions, right? So that's the optimal kind of conditions for a solution to be optimal. So that's the KKT. KKT condition actually can tell you whether your solutions are optimal or not. Besides, it can also directly solve out a solution, right? So I hope that by solving the homework, you can get a sense of the usage of KKT conditions. So for today, we are going to cover like three different things. Number one is how do we deliver the remote lectures, right? Especially for the project and the exams. And then the topic of today will be the discrete optimization. So we will spend like 2 lectures on this topic because it's very hard. And then I will give some like a simple algorithms to solve discrete optimization. So let's say first thing first, let's talk about the remote teaching. So remote teaching is actually what we are doing now, right? So the idea is we are using this kind of a Zoom to deliver all the lectures. Hopefully that there's not too many like issues, right? So the Zoom link will be this kind of a highlighted link. So that will be this, always be this kind of link. So every time you want to join the class, just join. And also I understand that so there might be some connection issue for some of you. So let's say if you are staying at home, but your kind of bandwidth is somehow pretty narrow, right? the connection maybe is poor. So for that case, I will also record the overall lectures and upload it to the YouTube and post that link to Blackboard. So you can have a kind of, watch the overall lectures later. And also, there might be some kind of questions when you watch the videos. So you can actually post the questions on Blackboard, especially in the discussion forum, right? We hope we can use that kind of a discussion forum to share our informations. Or maybe the easiest way is you can email me about your questions, right? When you watch it. So that would be another way to address questions. So that's the major kind of a change for the remote lecturing. Again, this is somehow, if you have any issue with connecting the Zoom, Blackboard, and email, just let me know, and we can do that one, right? So again, the lecture will be recorded and uploaded. Any questions you can ask, just email me or just post the kind of questions on Blackboard. So besides the lecture, there are some other communications between us, right? So the number one is office hours. So for office hours, because we don't need to have like a face-to-face meeting, so the time will be very flexible. So which means you can actually ask for office hour anytime from Monday to Friday. So pretty much that you just email me, say that you have a question or you want to have a kind of schedule an appointment, so I can hopefully try to schedule the earliest time for you. So that would be the way to schedule the office hours. And again, for office hours, we will use the Zoom, the same Zoom, right? The same link, so we can kind of communicate face to face. Hopefully, that's the way we do office hours. And also, there are some other general information. Mostly, I will create an announcement in the Blackboard so that I can directly email to you, right? So that's the way how I directly share information to you. So that's number one. Another one is for the discussion forum. So probably I will try to create more or post more thread so that everybody can make full use of the discussion forum. So I occasionally received some email from you regarding the homework. So mostly I directly reply to you, right? But I hope that you can actually share this information or share my replies to the whole class by creating a kind of discussion thread so that everybody can know the answer to it. Because some questions are pretty common, and so don't be shy to share the questions and the answers to it. Again, the email will be the simplest way to find me. So I will check the email pretty frequently. So hopefully I can give a very prompt answer for the questions over there. Okay. Let me see, how can there's no, hold on. Is everybody there? It seems that there's no voice. It makes me like, feels very uncomfortable. Okay, good, that's wonderful. Okay, that's wonderful. Yeah, hopefully that, okay, good, wonderful. So again, any questions you can also tap here so that we can, okay, good, wonderful. So I hope that we can really have some so this is a kind of challenge for me. So sometimes when I give lectures, seems I'm giving lecture to nobody, right? So that feels very weird. Okay, but it's nice to have your replies here. That's wonderful. Again, so communication, that would be this kind of things, right? Zoom will be number one, and email will be the number two, right? So that would be the way we can communicate. Here are some two major stuffs in our class. The first one will be the project. The second one will be the exam 2. So for the project, we have two things. Number one is the project presentation. So based on our syllabus, right, we need to present your kind of project. The idea is that Again, we will use Zoom to do the presentation. So just use this kind of Zoom. So I will give you the kind of access, or you can directly share your screen to us. Then that's how you present, right? So pretty much that you unmute yourself first, and then you can share your slides. So that's the way we can do the presentation. Everybody can join, right? So the point is there might be some issue. The thing is that some students may don't have the access to the Zoom, or just things happens, right? So if you cannot join the presentation at the right time, what we will do is we just skip your presentation, and we can pretty much do is that you can record your presentation later. And the PowerPoint actually have the function that you can record your presentation, right? It will record your voice and also your screen. So in that way, you can record it and email the video to me. So I will, if you don't know how to do this, so just let me know. I can show you how to do that. So probably, yeah, I will show later. But pretty much that, again, there's some like a plan B. If you cannot present online, you can actually present offline and email me the kind of recording. But I hope everybody can join online, because I can give you direct communication, or you can, directly answer my kind of concerns or questions about your projects. Otherwise, I will only email you the questions, right? Which is not good. So that's the presentation. Besides that, there's 1 week before the presentation. That would be the April 20th and April 22nd. So for these 2 days, I will set up an individual meeting for each group to check your progress and any issues you may have, so that I can kind of give you a very I would say prompt feedback, so that you can do some like kind of adjustment to your project, right? So that would be the 1 week before the presentation, April 20th. I will say this kind of individual meetings later. So pretty much each group will have some time to talk about your project and your kind of progress. Okay. That would be the project presentation and meetings. So any questions here?
So are you just gonna set up a time with us, or do you want us to respond to you to say, hey, can our group meet at this specific time? Which
I prefer that we just meet at the kind of lecture time, just normal time, from 5:30 to kind of 7, Monday and Wednesday. So that's a normal time. But I understand some groups may need extra time or more time to discuss the projects. So we can do anytime. You just schedule an appointment with me. But mostly that I think the individual meeting will be just the lecture time. Is that okay?
Yeah, fine.
So that's the way we do this. Yeah. So I will schedule some time. I will have a kind of Excel. So let's say for example, from 5:30 to like 6. So which group will, talk to me, something like this, right? Because we have like about 17 groups. That's a lot of groups. So probably we need more time on this. But yeah, so I think that would be the easiest way to schedule this, right? Again, if you need more time, we can schedule later. Okay. Actually, you can schedule a meeting with me starting from now, right? So you want to say have a detailed feedback. So because again, I already kind of give your feedback on your kind of project, right, through the Blackboard. But if you are not clear about my feedback, or you have some concerns, actually we can schedule a immediate kind of appointment to discuss your projects. How about that, right? So again, go ahead.
I was just saying, sounds good.
Okay, wonderful. So that would be the way we do this. Again, April 20th, that would be the kind of only 1 week before your presentation. Maybe it's too late, but again, this is a kind of a critical time to kind of to correct any kind of catastrophe, or something like disaster, right? So that would be I think that would be very critical to your project. Okay, so that would be the 2 things for project. Next, that would be the exam 2. So for the exam 2, again, it's take home. So just, which is good, right? So we don't need to have to meet with each other. So just take home. And also you will have exactly 1 week to complete this exam. So before the exam, I will give you like kind of samples, but it's not really the same. Give you some more details about the exam 2, 1 week before that. So actually that would be like, our exam will be 2 weeks later, right? I think that would be the 2 weeks later, April 6th. So that would be the starting time if you look at here. Let me see, can someone show me? We can use the later point here. So can you see the later point?
Yep.
Okay, wonderful. So that would be the April 6th. That will be the time I will post this kind of exam, the PDF to there. So it's just like a homework, okay? Homework like style. And also there are in the folder of assignment. And you will have 1 week to complete this kind of homework and then submit to Blackboard. And the due date will be April 13th, Monday, and 5:30 p.m. So I do recommend you can submit early. For example, you can submit on Sunday, sometimes, okay? Just to avoid any kind of connection issues. I think 1 week, that'd be super sufficient for you to complete the homework or this kind of exam, right? So that would be the things. So don't wait to the last minute. And so late submission will not be accepted. So some kind of reason like, oh, my computer kind of dies, something like this. Okay, I don't accept that one. So I hope that you can actually submit, at the right time. There might be, again, I just try to submit early. And also probably you can submit multiple times. For example, like Sunday, submit 1 version. And on the Monday morning, submit another version. Maybe this is also okay. But just make sure that for each submission, you have all the files. Again, the homework or this kind of exam will be like homework. So you have 1 PDF and also multiple the MATLAB files, okay? So that would be the kind of homework-like style. You might need somehow ensure that every submission have all the files, okay? So that would be the homework. Any issue here?
Nope.
Okay. That's cool. So pretty much that we hope that the homework or this kind of exam should be very smooth. Okay. The content of the exam will be just coding. There might be some like computing or derivation, but it's minor. The majority will be coding within MATLAB to solve problems. Okay. And plottings. So that would be the things. And all the kind of things, you can actually find the examples from the previous homework or my lectures. So that would be the self-contained test. Okay. So that would be all about our remote kind of learning, right? So using Zoom to do the lecturing and project exam will be remote. Okay. So if you don't have any questions, we're going to talk about our topic today. So our topic will be discrete optimization. So for discrete optimization, the point is, this is a very hard topic. So discrete optimization, but it's very useful. We will spend like only 2 lectures today and on Wednesday's lecture. So this 2 hours, about 2 hours, right? It's a very limited time. So I to, it's very hard to cover everything about discrete optimization. So my way to do this is actually, let me just trying to mute something. Okay, there's something wrong with my, just mute it. Just 1 second. Let me mute the, okay. So we will actually have very limited time to cover this topic. So I will only give you some very simple kind of examples and algorithms, or some kind of just give you a flavor of this kind of discrete optimization. Try to convince you that it's very useful, but also it's very, very hard. So let's say for discrete optimization, the key feature is that this optimization problems, the decision variables are discrete. Discrete variable means, so for example, integers. Let's say, for example, we want to say like how many passengers we should take for kind of a one drive, right? Or kind of one ride. Or how many tables should be placed in our classroom. There might be 5 or 6 or 7. So there should be some the optimal numbers, right? So that everybody can have a seat, and also the room should be kind of like looks very tidy. So that's something like tables, this kind of things, right? They are pretty much countable, right? You cannot have 1.12 tables, right? Also, you cannot have like 2.5 persons, right? Because this kind of variables, they are discrete, right? They are kind of integers. There's no way to have a partial of them. Also, for example, when you order on Amazon, right? For example, if you order something on Amazon, so pretty much that you only have a 1, 2, 3, 4, 5, like this, right? You only have an integer number of the items, right? So that would be the decision variables. It's most likely integers, okay? So this is a very different from our previous problems. Our previous problem says that you can be any numbers, right? For example, the temperature could be 1.15, something like this, right? It could be any numbers, any kind of a continuous numbers. But here, you only have limited selections. It's not limited, but somehow it should be rounded up, right? You cannot have a partial of them. So that's the kind of integers. The second kind of a variable, or the second type of a discrete variables, is binary, which is very common. So let's say, again, for most decision actions are binaries. For example, in your problem, you may have like yes/no questions, right? For example, let's say, do you want to join this kind of lecture, right? Or are you going to do something, right? That's something like you can say yes and no. So it means like a 1 and 2, or a 0 or 1, right? That's just 2 numbers or 2 options. So that's the decision actions, right? For example, let's say for this kind of COVID-19 crisis, right? So our president, our like Purdue president, need to decide in like whether should we, allow students to do remote lecture or not, right? Pretty much that's just one is yes or no, right? There's no other options. So most decisions, they are binary. You only have 2 kind of options. So that's somehow it's discrete. But it may look like this problem seems very easy, right? You only need to determine whether yes or no. But actually, there are many kind of binary variables that they appear in the same problems. For example, like Facebook, you need to connect everybody, right? So if I want to know how many people are connected, right? This kind of things, they are if you are connecting with me or not, right? There's many different connection groups or couples, right? These are, I would say, in a single problem, there are many kind of binary variables. So I will show you later about this kind of things. But I will try to convince you that binary decision variables are very common. Okay, the third type will be the limited possible numbers. So for example, if we want to design something, right? So we want to use a screw to tie 2 bodies together, right? So the thing is that we only have limited number of selections, right? For the screw size, they're pretty standard. You only have like a quarter or 1/8 or something like this, right? You have only very limited selections. So that's although these kind of selections, they are not binary nor integer, but they are limited. So these are pretty much three types of discrete variables. But the most common use will be the binary and the integer ones. So this is how the problem becomes discrete, because we have this kind of discrete decision variables. And actually, the decision, this kind of discrete optimization problems, they are pretty natural and they are very useful. Almost, everything are connected to this kind of discrete optimization. So here in this slide, I actually list some of them, right? Some kind of problems that actually you are kind of affected or you are involved every day. So again, for the discrete optimization, actually, it is a very important kind of topic. So some people also call it operational research. So it's called OR. So probably you know this, right? OR. OR is actually the major topic for the industrial engineering students. So they're trying to figure out the optimal kind of decisions, right? But in their problems, so they have a lot of discrete variables. So that's called OR. So for OR, it's a very important subject, but we have just 2 hours to cover them. But again, here we list several kind of applications. For example, the supply chain. So for supply chains, again, is that you need to, for example, you need to determine how many quantity you need for some like a kind of a demand, right? How many things you want to buy. So that would be the kind of supply chain kind of a decision. And also for the transportations and storages. For example, for the USPS or kind of FedEx, so they have to determine how to optimize their logistics so that they can actually minimize their transportation costs, but also they can actually deliver all the packages, right? So that supply chain somehow is pretty, kind of ubiquitous for, it's everywhere for us, right? And so because we receive packages almost every day or every week, right? So that's something like the supply chains applications. And all the models in supply chains, they are actually integer or kind of, discrete optimizations. So a lot of people, a lot of PhDs, or a lot of, engineers, they are actually working in this kind of things, trying to improve the efficiency and or the other kind of performance of the supply chain systems. So Amazon is the best one, actually. It can actually optimize the storages, transportation, and all the things. So these are something like for one applications. Another one is scheduling. So for example, maybe you don't realize that these kind of things are actually optimization. So for example, for the flight, right? So you need to, so for the flight control, so people need to kind of have a very good scheduling for each flight, when to fly and when to, kind of a landing, right? So this kind of things actually are discrete optimizations. So mostly they are kind of scheduling them in terms of minutes. So which minutes? It's not continuous actually. So it's for a minute. It's kind of a discrete version of it. And also for our course, for example, why our course, this kind of MET503 is actually scheduled at 5:30. So there are some kind of reason for this one, right? I think number one reason is that maybe we don't have enough kind of resource for the daytime kind of classrooms, right? That's why we are arranged to this kind of very evening class, or then some other constraints. But mostly is that we actually scheduling this course based on the time and also resource, so which are kind of discrete, okay? So the time is discrete. So we don't really want to start from like 31 minutes, like 20 seconds, right? We don't have this kind of continuous things. We only need to say 5:30 or 5, right? That's just 2 options. So mostly these are discrete. So also for scheduling, so for projects, actually project management, you have, you need to, decompose the project into many tasks, right? Many small tasks, and each task may depend on the previous one. So we have a kind of a lot of dependence relationship, but you want to complete the task in a very efficient time. So you have to arrange their sequence, and so that you can have the best project management. This is also discrete version because you determine what's the next kind of task is, right? So that's a discrete version. The third one will be routing. So routing means like navigation, something like this, right? When you are using Google, right? If you want to go to like India or kind of Chicago, so of course for now you don't want to do that. But if you want to go to like Chicago, you have to use Google or some Apple's map, right? So you can search the locations and then it will automatically generate some paths for you. But the underlying technology is pretty much the discrete optimization. It will evaluate all the possible routes, all the possible paths, and give you the best one. Because there are, there's a kind of a millions of different ways to from our Purdue to Chicago, right? But the kind of the Google will generate the shortest one or the fastest one to you, right? So this will be the routing. It's also discrete version. The decision variable will be which kind of a path you want to take, right? Which kind of at each kind of intersection, or at each kind of intersection, which way you want to go, right or left, something like this. That would be the integer, right? You only have a few, only 3 options, right? For each intersection, you want to go straight, right, or left. So that will be the kind of a discrete version, but it's pretty powerful for this one, right? Another one will be the floor kind of planning. So that would be the kind of it's kind of like a layout for components. So this is a very kind of a popular problem, right? For example, like in factory or in these kind of when you are placing the equipment, you want to have the best locations, right, for all the kind of components, so that your manufacturing or your I would say your production line will be very efficient. So this is also for planning. They are actually trying to say how many components we need and how to place them. So I think that will be the also belongs to the area of discrete optimization. Recently we have Uber, right? And so for Uber, actually, it's a problem of assignment. So we have for example, 10 maybe a million drivers and a million kind of passengers, right? So you need to assign that each passengers to a driver so that everybody can have the ride, right? So this is also a discrete version. So you need to pick which driver you want to for the kind of passengers, right? So that's integer one, right? So that would be the kind of assignment problem. Similar story for Airbnb. So all these kind of things, they are more like a discrete version. And there's many tricks to solve these problems. But although there are many kind of applications for discrete optimizations, there's a very good there's a very great challenge for this problem is that I would say here the discrete optimization problem is very hard to solve. I would say very, very hard. So there are many kind of ways to see the difficulties. Number one is that so there's no general algorithm to solve the discrete optimizations. It's not like our previous lectures, right? We say like for example the gradient-based method actually can solve most of the continuous problems, right? So that would be the good thing for continuous problems. But for discrete version, there's no general algorithm for it. And if you have some algorithm which is very efficient, but most algorithms, they are only able to solve some problems. It's more problem-specific algorithm, which means this algorithm is kind of intended to solve this problem. It cannot solve other discrete optimization because there's many types of discrete optimizations. Okay, and thirdly, that even though you can have some algorithm to solve the problem, but there's no guarantee that you can find the optimal solutions. So actually, most algorithms can only find the relative good ones. They cannot find the optimal one. There's no guarantee for that one. Okay, so that's why the optimization problem is very hard. The reason I think the curious is that you can have a millions of different combinations for the integers, right? It's hard to compare, it's hard to evaluate all the possible solutions. And also there's no way to use like a gradient or some other information. So that's the key reason. This is why this is so hard. So again, I'm trying to convince you it's hard, but for here, I'm also say that in this 2 hours lectures, we're actually trying to solve some very representative problems, although they are simple, but pretty classic. Pretty much that we will cover 3 very simple but very representative problems. So number 1 is our our old friend. We say minimal surface area of a can, right? We want a can to hold some volume, but we want to minimize the surface area to reduce the cost of the material, right? So that would be the first problem. And then the knapsack, maybe you already know the name of these problems, right? But in this lecture, I'm trying to give you some kind of insights or ideas how to solve them. For example, knapsack and the travel salesman problem, which is very classic, but it's very hard to solve. So for the following time, let me see how many time I have. I have like about 40 minutes. So we're trying to introduce the 3 problems and also introduce 3 algorithms to solve them. Okay. So the first problem, we already know this one, right? We say that we want to design a kind of a can, right? It's kind of a Coke. We try to, minimize the surface area, right? And the constraint is that this can will hold at least 5 milliliter liquid. So that's the constraint if you want to say here, right? And also, of course, the design should be positive. So this is our previous continuous methods. So, but in actually, or in fact, in the real world, so people hope that the D and H, they are kind of integer or discrete. So for example, even if you generate some solutions, for example, D is, for example, 8.156 something like this, right? You will not really need so many digits, right? You will only you need to round up to some numbers so that it's easy to design or specify in the document, correct? So that would be the way in the real world we most likely we'll use some like integers or discrete versions. So we like some round numbers. So that's why we say, let's say, how about DH? They are kind of integers. This is kind of a makeup constraints, but it's true in most real world. The people hope that their decision variables will be somehow a round numbers, right? So, for example, if you are kind of optimizing the price of a kind of some kind of a goods or foods, you hope the price will be some like $10 or $11, right? Other than many like 11 point something, right? So that's why we need some integers or kind of a discrete version. Okay, so that's a setting for this problem. So most likely that also in this problem that we only add additional constraints that the decision variables are integers. Okay, so that's the only. This is a very simple version to create a discrete optimization problem. The second problem, that will be more natural. So this is called the knapsack problem. So the setting is that you have a bag or kind of knapsack. This bag has a maximum weight capacity. For example, here, this bag can only hold 15 kilogram items, right? If you have more than this kind of weight, so the bag will be kind of damaged. So that's maximum. And you have a bunch of different items, right? For example, here, we have 5 different items. And each item, we have some weight and also the value, right? For example, this kind of yellow one is 4 kilograms, right? Which is heavy, but they have $10 for the value, right? So we have this kind of things. So your target is trying to pack this kind of items into the bag. but you have to, the total weight shouldn't exceed this kind of 15 kilograms, right? So the question is that what's the maximum value you can pack? For example, you can pack this yellow one and this kind of orange, this kind of two things, right? And pretty much that you can pack them, and then you can get like $11 for the value. But what you cannot do is that you cannot pack all the stuff inside it, right? Because in total there will be more than, let me see, I think, let's say 12 plus 1, that's how many? About 20 kilograms, that's too much, right? We have to, regard some items. So that's this optimization problem, is that which atoms or what kind of atoms you want to pack them. Okay, everybody get the setting?
Yep.
Okay, so the setting is this. Okay, so hopefully everybody can have a sense, right? You want to, you can think of some methods how to solve this problem, right? If you have a bag, you want to pack something, right? What's the best way to pack so that you can have the maximum value, right? So that's the very classic setting. The third problem is also a very representative optimization problem. So let's say we have 5 cities, for example, 1, 2, 3, 4, 5 cities. Each city, there's a coordinates, right? They are kind of, for example, this is 5 different cities. And your goal is trying to, travel each city just once, right? You can form a circle. And the point is, for example, you start from the city 1, you want to travel all the other cities once and then come back to the city 1. And the question is that what is the shortest way to, visit all the kind of cities, right? This is a travel salesman, right? You're trying to minimize the total travel time, but you can also kind of visit all the cities. So that's the kind of setting, correct? Have you heard of this problem, travel salesman?
Yeah.
Okay, that's good. Kind of, right? So pretty much that everybody knows somehow a little about it, right? So the problem is, do you know how to solve it? So we have introduced 3 different problems, right? This is the first problem will be the very conventional one, but we artificially add some integers there, right? Integer constraint there. So that's the first one. The second one will be kind of, a 0, 1 or binary, decision variables, right? You want to say whether you want to have this atom or not. So it's most likely a binary decision variables, right? So that's the second one. The third one will be a kind of like an integer one. For example, starting from city 1, what should be the next city you want to visit, right? You have, for example, if you start from city 1, you have actually 4 different options, right? So what's the best you want to go? So actually that's kind of an integer programming. Again, these 3 problems, they are very classic and also they're very hard to solve. So for this lecture, we will talk about 3 very simple algorithms to solve them. And the next lecture will introduce the rest 3. Okay, so the rest, kind of the 3 methods in the in the bottom, they are kind of marked as gray color. So these 3 methods, they're pretty kind of decent, but also very hard. So today we're gonna talk about the 3 simple ones, right? So the first one will be brute force, relaxation, the third one will be gradient. So that will be the total 3 things. So actually you can think about it. So for example, for the first problem, okay, let's say for this kind of a knapsack problem, right? Oh, for this kind of a, my bad. Actually, this is a travel salesman. I apologize for this one. This is a travel salesman, right? So we have 5 cities, right? We have 5 cities, and which route should we take, right? So the simple solution will be Let's say we start from the first city, and then we just, list all the possible way, right? All the possible way to travel this kind of 5 cities. For example, we start from the first one, and then the second stop will be the 5th one, and then the 4, 3, 2, right? Or we can change to the other one. So you can actually list all the possible solutions, okay? There are actually 24 different types of it. By the way, do you know how to generate this kind of 24? Or can you list 24? You know the logic to list all of them? So if you look at this kind of table, so for the first one, right, that's it's fixed. We just start from the first city. And for the next stop, you may have 4 different options, right? For example, this is the first option, second option, third, and the fourth one. And for the third, that's very correct. Thank you for Hannah. So that's correct, very correct. So for the second stop, you may have 4 options. And after the first 2 stops are determined, for the third stop, for example, for this one, 1, 5, you will have 3 different versions, right? For example, you have from 1, 5, you can have 4, 2, 3, something like that, right? So pretty much that at the second stop, you have 4 options. The third stop, you have 3 options. The fourth one, you have 2, and last stop, you have only 1 option. So that's the Handler's kind of equation. The total number of solutions will be 4 times 3 times 2 times 1. That's the total number of the passes, right? And which is, you can see here at the very bottom, I already said that if you want to list all the possible solutions, you have to evaluate how many. It's the factorial of n-1, right? Anybody get a sense of this, how large this number is, the factorial n-1? So pretty much that would be the largest possible numbers actually. This guy is actually much faster than the exponential one. So n-1 is much faster it's even much faster than exponential growth. So which is a very, very huge number. If you have like 100 different locations or cities, this number will be, kind of a number that is close to infinity. There's no way to evaluate it. So if you use brute force, so the problem is that if you only have a few cities, that's fine. You can evaluate all of them. But if you have a lot of them, like for example, 100 cities, then it's impossible to list all of them. Okay, so that's the downside of this kind of brute force. It's just impossible to list all of them. Okay, let's say another problem, our real knapsack problem. So for this problem, correct? So this is a knapsack problem, right? We have a bag, and we want to, have 5 different items. So the decision variables here is, should we cover this one or not? Should we include this one or not, right? That would be just 2 kind of options or binary decisions, right? Either 1 or 0, right? So for example, we have x1, 2, 3, 5, so represents 21. For example, for the first, here again, because we are using brute force, we are trying to list all the possible solutions, right? So the reason is, let's take a look at the first solution, right? So x1 is 0, x2 is 0, and everything is 0. So what does this mean? If every decision variables is 0.
None are chosen.
That's correct, right? It's empty. We don't choose any of them. And for the last one, that will be all 5 ones, which means we pick all the items. But the point is, you need to compute for each kind of combination, you need to compute the total weight of that combination, right? And also the total value of it. For example, if you pick nothing, then there will be 0 weight and 0 value. But if you pick everything, for example, if you pick everything here, then your total weight is about like 20 kilograms. It's, you know, this is infeasible, right? And I know that the value will be the largest one, but it's infeasible, so we don't want this one. So based on this table, what is the best option here? Just give you some minutes to think about what's the best option.
28.
Okay, that's good, right? Everybody can quickly find the 28, right? So pretty much that you can find that if you exclude all the infeasible solution, then the largest guy will be 15, right? That would be the total value, $15. That would be the total value for this problem, right? Given the 15 kilograms. So just remember this solution, 15, we'll use it later. But the idea is that, so for this 28, this kind of solution, let me see. For this kind of solution, right? So it means, what does it mean for this kind of 11011?
You select items 1, 2, 4, and 5, and you do not put item 3 in the bag.
That's very correct, actually. So very good. Pretty much that we don't need the F3, right? Because that's, you can see that this is a pretty, you know, it's very cheap item, right? We don't need that one. So that's the idea of it. So pretty much that we just pick all the 1, 2, 4, 5, which can give us the maximum kind of value that's within the weight constraints. Okay, so this is a way to list all the possible solutions. And the thing is that the same problem with the previous kind of travel salesman, right? So you have to evaluate all the possible solutions. So how many solutions for this? For example, if you have 10 different items, how many solutions you need to evaluate? For 5, this is about 32. Yeah, I got a number. This is 2 part of 10, right? Pretty much that you need, it's exponential, right? This is the total number of the solutions will go crazily, right? So this is impossible to, if you have n equals like 100, that's also a very huge numbers. But again, this kind of exponential, actually it's smaller than the kind of a factorial this number. But again, even for exponential, it goes crazily, right? So there's no way to solve them if you just use brute force. So the idea is, how can we have a better idea to, you know, get some solutions from it, right? Without evaluating all the kind of options, right? So that's the kind of the key reason or the key ideas for discrete optimization. You don't want to evaluate all the solutions, but you only need to pick some of them and get some information from it. So actually, there are 2 useful methods. They are pretty simple. The first one, beyond the brute force, that would be relaxation. So relaxation is, so for example, for this problem, our problem is we have a b and h, they are integer, right? This is the problem comes from, right? Because when we add these constraints, we hope that d and h, they are integers. So that's a problem comes from. So how about we relax this kind of constraint? We don't consider it. We just remove it, right? We don't consider this kind of constraint, and then we solve it. So that would be the 8.61, something like this, and h will be 8.6. That would be the solution for this continuous problem, correct? But of course, we hope d and h should be integers. So what should we do? Either way, I would say just round up, right? So for D, that would be 8.6. How about, we know D should be integer. Let's just put 9 about it, right? And H just for another 9. Then problem solved, right? So this is the meaning of relaxation. So the idea is that we have trouble with kind of discrete variables. How about we just assume they are kind of continuous, right? We regard them as continuous variables and then solve this kind of problem as a continuous problem, continuous optimization. And after we figure out one solution, we can actually round up, right? So that's the idea of this kind of methods, correct? Any issue with this one?
No issue.
No issue. No, okay. But I mean, can you see some downsides for this kind of a problem, or like from the, you know?
It's less precise.
Yeah. So it's somehow correct. So number one is that if you remove this kind of a constraint first and then round up, so you will actually lose some kind of a precision, or sometimes you will miss the best options. Number two is that sometimes you need to consider some round down, right? For example, there are some kind of a, you know, a 8 line or something like this, right? Or, you know, there are many like -1 or +1. There are some different roundup things. That's something you need to take care. But these kind of downsides are okay. I think the most important is that for some problems, actually, there's no way to relax it, because in this problem, we know the continuous problem, right? And then we actually relax it. So that's the way we know the corresponding relaxation problems. For most problems, somehow it's hard to find the corresponding continuous problem. That's one issue. Another issue is that if you assume it's continuous, then the whole problem will be very different. And most likely, this problem is not the original one. So I would say for most discrete kind of optimization problem, you can try to use relaxation to solve it. But highly possible you will be disappointed because it just doesn't work, okay? So relaxation is simple, but you can try for the first time and get some sense of it. But most likely you will, you know, get a very, you know, you will miss the best point there, okay? And also it's very hard to model a continuous version of it. So sometimes that is the problem, okay? So for relaxation, I think everybody can know the idea, right? Just relax it. I think besides relaxation, another very good way is called greedy, the greedy methods. So for greedy methods, actually that's a very commonly used way to solve discrete optimization. From the name, we know it's greedy, right? Greedy means sometimes you will miss the best point, but because it's greedy, so you can easily find the solution of it. So I'll show you how. For example, here, so our greedy is that you can figure out some like greedy rules to formulate a solution. For example, for this kind of a knapsack problem, right? So what should be the greedy approach or the greedy policy? So think about this. If you are the guy, right, you want to pack some items in your bag and you want to, you know, select those items, what kind of a policy or rule you want to pick? What's the easiest way? Always pack, what do you mean? You mean at each time just pack one and then?
I think what he means is pack X1 as much as you can until you hit 15 kilograms.
You mean packs X1, right? Okay, packs a box, that's cost. Why do you want to choose the X1 as the first item?
Has the most value and it's for its density.
Yeah, it's most expensive one, right? It's density. I agree with that one. It somehow looks more, reasonable, right? To pick the one has the, this kind of thing, right? The most valuable item per weight, correct? I would say. The bigger, yeah, I think Hannah's get the point. Pretty much is that we have a list of the each item's value weight ratio, right? So for X1, that's 2.5. That's the most valuable item, right? Because the weight is somehow medium, but the value is okay, right? It's pretty good. It's $10 for 4 kilograms. So that's the key items, the key things, right? You want to start from the most valuable item per weight first, right? Sequentially pick them. After you pick the first one, then you want to pick which one? Next two, right? That's because it have two, on average, it's about two kind of a bucks per kilogram, right? So we actually can rank or you can kind of sort their price weight ratio or value weight ratio, right? You can say X1 will be the most valuable one per weight. X3 is the least one you want to pack, right? Because it's very heavy, but the value is so small. So that somehow you want to use X1, 2, 4, 5, and 3, right? And then you just pack one by one, right? For example, you just pack the X1 into the bag and X2, X4, X5, and eventually you can see that you can only pack the first 4, right? So X3 is too large, you cannot pack it. So that's the way we form this kind of algorithm. It's pretty simple, right? It's greedy, actually. This is called greedy. Greedy means you have some kind of your human insight of this kind of things, right? Because we want to maximize the value, but within the constraint, within the weight, which means if one item has a very high, value ratio, which means it's pretty, valuable, right? We want to add it there. So that's a greedy kind of comes from. Again, you can see that this greedy approach is very specific to this problem, right? So for other problem, you have to generate some other greedy approach to it. So that's why greedy somehow is more like you need to be kind of smart to generate this kind of approach. It's not really a universal or general rule to generate some kind of greedy methods. It's mostly problem specific. And if you look at the value 15, right? So remember the 15 numbers previously? I think previously we used the kind of a brute force, right? We list all the possible versions, and the 15 is actually the best one, right? So 15 bucks, that's the optimal one. So in this problem, using the kind of a greedy approach, we actually can find the optimal solution, but generally not. So for generally, if you use greedy approach, so the solution will not be optimal. That's a general case, okay? But this kind of a greedy approach based solution is good enough, actually. Most likely it's good enough. And also given that it only needs to compute the kind of the ratio, right? And then you can directly figure out the solution. So that's very simple for this one, right? So the computing wise, it's very efficient algorithm, and it can give you a relatively good resolution, a good solution. So that's the greedy algorithm, which is commonly used in discrete optimizations because it can quickly give you some kind of a benchmark solutions, okay? So that would be the greedy for the knapsack. Again, the greedy is very specific to problems. You will see this for the next problem for travel salesman here. Okay, again, for the travel salesman, we have like 5 different cities, right? And again, so what's a greedy approach to take? For example, if we, hold on, let me see, if we start from city 1, for example, that's our starting city. So what should be the laxity? Oh, I will tell you the answer. What should be the laxity you want to visit? The 2, right? I think Hannah is talking about 2, and so we're talking about the minimal distance first, right? So that's kind of a insight, right? That's your kind of a heuristic or the gradient. So that is true. So pretty much that we want to pick the closest city or the nearest labor, right? So that's pretty normal, right? So we don't want to go 3 or 5. That's too far away, or 4. So we directly go to the second city, right? And then starting from 2. So what's the next one? That's correct, right? We need to go to the 4, city 4, right? Because that's the closest city to the city 2, right? So this is a gradient. And then we can go to 5. From 5, because the only left city is 3, so we directly jump to 3, and then we go back to home, correct? So that's the way to generate a solution for travel salesman. Sometimes this is, again, it's a kind of a pros and cons for greedy approach. So you can generate some solution quickly, but you cannot guarantee the quality of this solution. So sometimes it's good, but sometimes it's bad. But generally it's good. It's better than random, right? So for random, you can pick, it's better than random. So you can play as a benchmark for your algorithm, right? So that's somehow using a greedy approach to solve this kind of discrete version. So that would be the kind of the methods or very commonly used method to solve discrete optimization. So if you don't have any, viable solutions or algorithm to solve it, just use this kind of a greedy based. But the point is that how do you generate the greedy policy? That's very somehow, I would say it's very intuitive, but also very hard. For example, in this problem, this might be very intuitive, right? Starting from the city 1, the intuitive one will be the closest city, right? But in some other problems, maybe this somehow is very hard. You need to think for a very long time to generate a good greedy policy. Okay, so this is some methods to solve it. Again, hopefully in this lecture I gave you some introduction to the discrete optimization problems and some simple or kind of a very easy algorithm to solve them. Relaxation is one of them, right? You just regard it as a continuous problem and then try to solve it. The greedy one will be very problem specific. You need to generate some greedy rules to find the good solutions. But again, these methods, so for relaxation and greedy, they cannot guarantee a good solution for you. Okay, but for brute force, so it's pretty, impossible for most problems. Okay, you need to evaluate all the combinations, which is impossible. Okay, so and then we have can see that the gray color, actually this kind of 4 algorithms, they are very decent and they can generate very good quality solutions. So we will talk about them in the next lecture. So for these lectures, that will be the 3. So I apologize that for this lecture, actually we talk too much, right? Especially for me, I talk too much. So I think at the beginning of the next lecture, I will show you some kind of MATLAB algorithms and show you some results, some visual or kind of things, right? Hopefully we can get a better understanding of this simple one and also the kind of the rest, the algorithms. I think I have one more slide. So this is the slides actually trying to say that there, for the discrete optimization kind of algorithms, it's as I said, it's pretty powerful. A lot of applications require this kind of optimization, discrete optimization algorithms, and actually that's the most the valuables. That's the opportunities people can make money actually. So for example, MATLAB, this, a lot of companies actually making money from this, providing the the software to solve problems. So I personally used like this the first 5. Actually, I used all of them. So they're pretty nice actually. So they have a very good way for you to formulate the problem, and then it can directly give you a solution for it. So you don't care about the kind of algorithms, but they are implementing this kind of mixed integer linear programming algorithms, most likely this, and then many some other algorithms. But for most problems can be solved using this kind of mixed integer linear programming. And the thing is that for Cplex, this kind of packages is very common. It's a kind of a core or kind of engine for most, kind of commercial packages for others. For example, Lindo, again, the games, they're actually using a Cplex. And for the group, actually, this kind of is another, kind of a rising star for solving the kind of discrete optimizations. So hopefully next lecture, I can show you some of them, okay? Of course, for our class, we only focus on MATLAB. So MATLAB is very good also. It has the core to solve the kind of, discrete version. So we can actually use the MATLAB to solve some like medium level kind of problems. So for all the like Cplex, Lindo games, they can solve very huge numbers of variables. They can solve very large scale problems. Okay, that's why they can make money from it. And also there is a kind of a wiki, list of all the softwares that can help you to do that. So also there are some like some links actually. Probably we need to use this link next lecture, but you can take a look at them. So the idea that would be I think all for today's lecture. So any kind of questions for this one? I think we have 3 more homework, right? 8, 9, 10. So I think for next, for this week, our homework will be something like using MATLAB to solve the kind of to solve the kind of travel salesman and the knapsack problems. So that will be the homework. But I will, officially do that on next, lectures. On Wednesday, I will release them. I haven't kind of write up the problems, but I will do it later. Okay, so again, so for this kind of 2 lectures, just give you some tutorials on discrete optimizations. Again, 2 take-home messages. One is that discrete optimization is very useful. Second is that it's very hard to solve. So that would be the the take-home message. But we can have a lot of kind of packages to commercially available packages to solve them. Okay, so any questions you may think of? I will upload this kind of recordings.
I have a question regarding this week's homework.
Okay.
I'm wondering, for problems 1 and 2, solving them mathematically, can we use MATLAB to solve for the variables x and y, or do we have to do it by hand?
So you can, you mean you can use MATLAB. Yeah, of course, if you can do that, you can do that too. But I think use mathematically may be easier. But if you think that you can use MATLAB to solve it, you can do it, right? Hold on. So you are saying is that you want to solve the equations or the whole problem using MATLAB?
The equations, like solving for the optimal point.
So you mean you have listed the KKT conditions? You have listed the equations, but you don't want to solve the equations by hand. You want to solve it using MATLAB, right? Yeah. Yeah, of course you can do that. Any method you want to do, any method you can figure out the solutions, that's fine with me. Okay. Yeah, go ahead. Yeah, actually you are encouraged to do that.
You want just the real solutions though, right?
Yeah, that's true. So that's very true. So, but I think I need to make some comments there. I think for the first problem, you may have two solutions, right? And it's okay if your problems have multiple, optimal solutions. That's good. But you need to compare these solutions to say which one is best. If they have the same objective number, objective values, then both solutions are acceptable. Is that clear? Okay. And oh, probably I may need to, I record one questions from the email. Is that when you solve the KKT condition or KKT equations. So for example, I think there's a, let me type the problems and the let me see. Okay, can you see my typing? 2x plus 2ux equals to 0.
Yeah.
Okay, so this equation, so actually you have two possibilities, right? One is x equal to 0 or the mu equals to minus 1, right? Correct? So the point is that it's or. So it's not really, they need to be at the same time. So because I think half of you think that x equals to 0 and the mu equal to minus 1. No, it's wrong. So you can either take x equal to 0, right? Using that as a kind of solutions, and then just remove this kind of equations, don't consider it, and then plug x equal to 0 to the rest of the equations and solve it. That's for the first case. And for the second case, the mu equals to minus 1, then just use mu equal to minus 1. The x could be any number, okay? There's no reason to think that x equals to 0 and at the same time, mu must be minus 1. They are separate, okay? There are two situations, different situations. So don't think they are kind of at the same time. They should be satisfied at the same time. This is very critical, which means if you are using x equal to 0, then just x equals 0. Mu could be any number, okay? Don't bound them, don't couple them together. Did I explain clearly?
Yeah.
Okay, that's wonderful. So I think that's why some of you get very weird with solutions, okay? So this is ors, they are not really, they cannot be the same, they cannot meet at the same time, okay? So that's the different situations, the two different situations, okay? Actually, they cannot be the same at the same time to be satisfied. Okay, so that will be something you need to figure out. Any other questions about the homework? Probably if you think of some questions about the homework, you can actually email me. Or again, I would prefer you email me, and then when I give you a reply, please share this information in the discussion forum, okay, so that everybody else can understand or can see that. That would be good. Okay, so I think that would be all of today's lecture. Okay. Okay, wonderful. Okay, bye everyone. So I'm stop sharing. Just email me if you have any questions. And also, when you watch this kind of video, you can also email me the questions if you have. Okay. So that will be it. So bye everyone.